Let's see what is standard form or scientific notation to write numbers. Standard form is really a special way to write numbers, and it is that kind of a special way which makes it easy to use very big or very small numbers. Now let's see how a number in standard form looks. The standard form number has two parts. The first part is a decimal number which is between 1 and 10. It can be any decimal number. It can be 1, but it cannot be 10. That means any number from 1 onwards less than 10, any decimal number. And the second part is a power of 10. That means 10 to the power of any number. And these two parts are multiplied with each other. That means the first part multiplied by the second part. Now let's see what does it really mean. Let's take an example and learn how this works. Consider 50. I can write 50 as 5 multiplied by 10. Why 5 multiplied by 10? Because my second part always needs to be a power of 10. That's why I have written it like this. So this equals 5.0 multiplied by 10 to the power of 1. 5 means 5.0. It's the same thing. And 10 means 10 to the power of 1. So what I've written here is 5.0 multiplied by 10 to the power of 1. That is called as standard form or scientific notation for the number 50. If the number is 500, then 500 can be written as 5 multiplied by 100, and 100 means 10 to the power of 2 or 10 squared. So I can write it like this, 5.0 multiplied by 10 squared. This is again written in the standard form. And for 5000, 5000 equals 5 multiplied by 1000, and 1000 is 10 to the power of 3. So this equals 5.0 multiplied by 10 to the power of 3. So all these numbers, 5.0 multiplied by 10 to the power of 1 or 2 or 3, all these numbers are written in the standard form or scientific notation. Let's take one more example. Let's consider 34. So I can write 34 like this, 3.4 multiplied by 10. If you multiply 3.4 by 10, you get 34. So that's why I've written it like this, 3.4 multiplied by 10. And 10 means 10 to the power of 1. So in standard form it looks like this, 3.4 multiplied by 10 to the power of 1. That means we are always writing the decimal point after the first non-zero digit. In the first part, what I have to write is I have to write the number between 1 and 10. So if I write the decimal point after the first non-zero digit, in this case after 3, then I get that between 1 and 10, right? So my first step is always write the decimal point after the first digit, the first non-zero digit, multiplied by the second step is 10 to the power of something. So that means now I have to figure out what is the power of 10. That will be my second part. And this can be figured out by counting the places the decimal point moves. That means you check how many places the decimal point moves, and based on that you can write the power of 10. What does this mean? If you look at this number 34, 34 is really 34.0. For the whole numbers, we do not write the decimal point, but it is there even if we do not write it. The decimal point is after that number. That means when I write 34, what I really mean is 34.0. So the decimal point is after 34. When you are moving the decimal point so that it comes after 3, that means the decimal point hops over the digit 4 and it comes right after the digit 3. That means you have moved the decimal point by one place. And this number is the power of 10. Let's take one more example. Say 340. 340 can be written as 3.4 multiplied by 100. That means 3.4 multiplied by 10 squared. In this case, the decimal point has moved 2 places. It was after 0. 340 means 340.0. It was after 0. It has hopped over 0 and then hopped over 4. That's why it has moved 2 places. So the answer is 3.4 multiplied by 10 to the power of 2. In case of 3400, the decimal point hops over 3 digits. So the answer is 3.4 multiplied by 10 to the power of 3. The first part is always 3.4 because we write the decimal point after the first digit, after the first non-zero digit. So in all these three numbers, whether it is 34, 340 or 3400, for all these numbers, the first part is always 3.4. And the second part, where you have a power of 10, the power of 10 varies because it is based on the number of places the decimal point moves. Now let's look at these numbers again. These numbers we have seen before, 5550. What happens if the number is smaller than this? That means if the number is 5. I can write 5 as 5 multiplied by 1. And how can I write it using a power of 10? Can 1 be written as a power of 10? We know that anything to the power of 0 equals 1. That means 10 to the power of 0 also equals 1. So I can write it like this, 5.0 multiplied by 10 to the power of 0. In this case, we haven't moved the decimal point at all. The decimal point was after 5 and it is still there. So when you do not move the decimal point, you are going to write that as 10 to the power of 0 because the decimal point has moved 0 places, right? So this works for any single digit number, whether it is 2 or 5 or 8. 8 means 8.0 multiplied by 10 to the power of 0. What happens if the number is smaller than this? That means the number is something like this, 0.5. 0.5 equals 5 over 10 or 5 divided by 10. That means 5 multiplied by 1 over 10. And now 1 over 10 can be written as a power of 10. 1 over 10 means 10 to the power of negative 1. So now I have written 0.5 using standard form. It looks like this, 5.0 multiplied by 10 to the power of negative 1. Now let's consider 0.05. So this equals 5 over 100, which equals 5 multiplied by 1 over 100. And 100 means 10 squared. That means 1 over 100 equals 10 to the power of negative 2. So the standard form is 5.0 multiplied by 10 to the power of negative 2. Now look at all these numbers carefully. The first three numbers are greater than 10. So when the number is 10 or greater, you always have a positive power. The power is always positive. And the decimal point moves to the left. If you look at 5000, the decimal point was after 5000, that means after all the three zeros, which moved to the left, and that's how it is after 5, and that's how you got 5.0 as the first part. So whenever you have any number which is 10 or greater, the power is always positive and the decimal point always moves to the left. Now if you look at the last two numbers, they are smaller than 1. When a number is smaller than 1, then the power is always negative, and the decimal point moves to the right. If you look at the last number 0.05, you can see that the decimal point has moved to the right hand side, and it has moved two places. It has hopped over 0 and 5, and now it is after 5. So if the number is smaller than 1, the power is always negative and the decimal point moves to the right. So the first part is when the number is greater than 10, and the last part is when the number is smaller than 1. And you know what happens when the number is in between 1 and 10. Then the power of 10 is always 0 and the decimal point does not move. Now let's solve some examples. Here is a big number, 1,372,000. Let's write this number in standard form. We know the first part is easy. We write the decimal point after the first non-zero number. That means the decimal point will be after 1. So if the decimal point is after 1, the decimal point is going to move to the left and it is going to hop over 3 zeros, 2, 7 and 3. That means it is going to hop over 6 digits. So this number is going to look like this, 1.372 multiplied by 10 to the power of 6. The decimal point moves to the left, so the power is positive. Let's look at another example, 0.00018. Now the decimal point is going to move to the right, because it should be after the first non-zero digit, which is 1 here. So the decimal point should be after 1. So it is going to hop over 3 zeros and 1. That means it is going to hop over 4 digits. So the standard form will look like this, 1.8 multiplied by 10 to the power of negative 4. The power is negative because decimal point moves to the right and it hops over 4 digits. So the power is negative 4. So now you know how to use the standard form or scientific notation. But I said in the beginning that this is really helpful for very large numbers and for very small numbers. So let's see where it is useful. Let's look at this. The distance between the Sun and Earth is 150 million kilometers. Now this is a huge number. Let's write this in standard form. In standard form, the first part is easy. The decimal point will be after 1. So the first part is 1.5 multiplied by, the decimal point is going to cross over 3 and 3 and 1. That means 7 zeros and 5. That means 8 digits. So the answer is 1.5 multiplied by 10 to the power of 8 kilometers. The distance between the Sun and Saturn is 1,400,000,000 kilometers. So if you want to write this using standard form, it will look like this, 1.4 multiplied by 10 to the power of 9. Because the decimal point crosses 3 plus 3 plus 2, that means 8 zeros and the digit 4. So it crosses over 9 digits. These were the examples of big numbers. What about very small numbers? Let's take an example of a very small number. The width of an atom is 0.000000001 meter. That means there are 3, 3 and 2, 8 zeros and 1 meter. Let's write this using the standard form. The decimal point should be after 1, the first non-zero digit. So it is 1.0 multiplied by 10 to the power of minus 9, because the decimal point has moved to the right and it has crossed over 9 digits. The diameter of a red blood cell is 0.000007 meter. So this number in standard form will look like this, 7.0 multiplied by 10 to the power of negative 6. The decimal point has hopped over 6 digits and to the right. You can see that this is quite easy to read and write in scientific notation. But you will see that it is also easy to do calculations using the standard form. Let's take an example. Suppose you want to compare the width of an atom with the diameter of a red blood cell. How can you compare? To compare the number, let's divide one number by the other number. So in the numerator I have the diameter and the denominator is the width of an atom. When you divide 7 by 1 you get 7, and now let's divide the powers of 10. The base is the same, so let's subtract the exponent. So it looks like this: 7 multiplied by 10 to the power of -6 minus -9. Minus -9 means positive 9. So -6 plus 9, that equals 7 multiplied by 10 to the power of 3. 10 to the power of 3 is 1000. That means the answer is 7000. So the diameter of a red blood cell is 7000 times that of the width of an atom. You can see how easy this was to compare, how easy this was to divide. This was just one example that we saw, but if you want to calculate area using very huge numbers or using very small numbers or do any other kind of calculation, that gets a lot easier using standard form or scientific notation.